comes under public key cryptographic algorithm. One is key exchange, and remaining two are the encryption algorithms. Okay, so here the encryption is useful to provide the confidentiality service. Okay, so when we are performing encryption, then we are getting the confidentiality service. Now we are going to discuss about data integrity. Okay, so to provide confidentiality, we are using encryption algorithms. So sometimes some of the attacks are possible. So we already discussed about the attacks. So man in the middle attack, modification of contents, replay attack. Okay, so these are the some attacks are possible even though we are performing encryption. There is no data integrity, there is no authentication. So to provide data integrity and to provide data authentication, now we are going to discuss authentication functions. So, what is data integrity? Can anyone tell what is data integrity? So we discussed about data integrity in some class. In lecture 2, already discussed about data integrity. So security services, confidentiality, integrity, availability, authentication, non-repudiation. So these are the main security services provided by cryptography and network security. So confidentiality means the third parties or any attacker cannot read the message. That's why we are performing encryption. Okay. Chappali, what is data integrity? Set of data. Okay, any other definition or any other information which you have to know about data integrity? Maintaining consistency, accuracy. Good, good. Data being transferred as original without any change. So then we can say that the data has the integrity, safety and correct data. Good. And as well as we have to identify the correct source. So when we are receiving the data, we have to identify the source is authorized or not. The source is the source, the data comes from the source. Source is authorized or not. Okay, we have to identify that. So that's why we need authentication. Okay, so this authentication provides the data integrity. Okay, so today I'm going to discuss about message authentication as and hash functions. Okay, what are the different types of authentication functions are there? Message authentication code, we also have MAC and hash functions, and types of the hash functions. So these are we learn today's session. Students already securely with any modification, and that integrity. Check integrity is to check data is the received data is okay without any modification. So just need to authenticate data. Okay, so
You say,
authenticate the data.
sir, your voice is breaking. That's not clear.
On now is okay. Voice is okay now. One minute, I disconnecting the meet and I will rejoin. Okay, now PPT is visible to you. Okay, and voice also clear. Okay, good. Maybe I switch off the fans. Now it's clear. Okay. సో ఇక్కడ రిసీవ్ చేసుకున్న డేటా కరెక్ట్ సోర్స్ నుంచి వచ్చిందా లేదా అనేది ఐడెంటిఫై చేయాలి. దాన్ని సోర్స్ అథెంటికేషన్ అంటారు. అండ్ రిసీవ్ చేసుకున్న డేటా మాడిఫై అవ్వకుండా లేదా అని వచ్చిందని తెలియాలి. సో అప్పుడు మనం ఇంటిగ్రిటీ అనేది కరెక్ట్ గా ఉందని చెప్తున్నాం. సో హియర్ ద అథెంటికేషన్ మెకానిజం message authentication is a mechanism or service is used to verify the integrity of the message. So integrity means without modification through the network, and it assures that data received are exactly sent by the originator. So here originator means sender. So sender is valid. Okay. And without modification of messages, without insertion of any message, without lossing of data, that is deletion, and without replay. And replay means here the data will be reached in correct time. So that will provide the integrity. Now, when we are searching a web page or searching for an information from the web, we have to identify the correct sender, and we have to take the data from correct source, authorized source. Okay, some trusted third parties maintaining duplicate data, so we cannot download it. Okay, because some websites having harmful applications, harmful information. When we download it, then some type of worms, viruses will be spread into our system. So that's why we have to identify the correct source. So here in network security, when we receiving the data, when the receiver receiving the data, it has to identify correct person, correct sender. Sender is also called originator. Now, any message authentication or digital signature. Okay, so to provide message authentication, we are using digital signatures. So, in today's session, we discuss about digital signature also. Okay, so digital signature is nothing but encrypting the message using private key. So, private key is only known to the sender, and everyone know the public key, sender's public key. So, they receive the ciphertext and decrypt with sender's public key, and they get the plain text. So when the receiver using only sender's public key, then only receiver getting the plain text. So it identifies that this message comes from sender. Why? Because it is decrypting with the key of public key of sender. Okay. So in that manner also, it authenticates the sender. So any message authentication or digital signature mechanism performing a function. So when data transmitting through network, okay, so the sender performs some function, then produces a value. So after the function, we are getting a value that is called authenticator or authentication code that is used to authenticate a message. Okay, so different mechanisms, we are performing some functions. In message authentication code, we are performing a function called C. In hash values, we are performing a function called H and getting the some fixed length value. So that fixed length value is called message digest in hash functions, cryptographic checksum in MAC, message authentication code. So to provide authentication to a data, first we have to perform a function, then we are getting some code. That code is called authenticator. So uh, So here we are having the message. So normally what we have to do is we are performing either public key encryption or symmetric encryption by using some keys. If we are using symmetric key, here we are using secret key. If we are using asymmetric key, here we are using either public key or private key. Then we are getting the ciphertext. Okay, so this ciphertext is received by the receiver and performing decryption with key and getting the same plain text. Here also key. Now here we are providing confidentiality. If the attacker receive this ciphertext and modify some bits and sending to receiver. Receiver, if receiver receive this modified ciphertext and decrypt with key, then it getting some message. But the message is correct or not, it has to verify. Why? Because some applications like in hospitals, okay, in hospitals, the doctor sending X-ray, okay, X-rays, X-ray. Now attacker encrypting this X-ray into ciphertext. So then the ciphertext in the form of zeros and ones. Okay, zeros and ones. Now attack this attacker or cryptanalyst modify some messages, modify some bits, and sending to receiver. So receiver using decrypt with key, corresponding key, and getting the plain text message. But the receiver doesn't know whether it is original image or modified image. Why? Because some modification is not much vary in the X-ray. And the same way, when sender sending some images, so this image is converted into binary based on the pixel values and then performing encryption and sending through network. Then cryptanalysis again modify some messages, modify some bits and sending to receiver. So receiver doesn't know whether the received message is a correct one or modified one. Okay, so there is no integrity. So to provide such integrity, here we are performing a function. So here we are taking the message and here we are performing some function and getting the code. This code is appended to original message and getting the original message as, so here original message, this is the code. Here we are performing function. Okay, so this code is called authenticator. Okay, this code is called authenticator that authenticates a message. So now the receiver receiving this code, okay, and performing function on this message, okay, performing function on that message and getting the code here, and this code is compare, okay, and verify the, if both the codes are same, then the message is not modified. If the attacker modify some bits in the message, then here the produced code and this code are different. Okay, so in this manner we can perform the authentication. So the authentication function is generated by, so this function is generated by message encryption, message authentication code, hash functions. Okay, so these are the different techniques to provide the message authentication. ఓకే. అర్థమైందండి ఇది? Now we are going to discuss about these three functions. So first one, message encryption. So encryption, you already read the different type of encryption techniques: symmetric encryption, asymmetric encryption. Here, this is symmetric encryption. So here, this is the source A and destination is B. So when source A sending the message, and here we are performing encryption with key and getting the ciphertext. So this is the ciphertext, and receiver destination receiving the ciphertext and performing decryption with the same key and getting the original message. So it provides confidentiality and authentication. So why? Because so confidentiality means in the network, okay, in the network, no other person can reading the original message. So it provides the confidentiality and authentication. So only sender and receiver, okay, only sender and receiver know the key. Okay, only sender and receiver know the key. So when receiver receiving the ciphertext, it decrypts with the key and getting the original message. Okay, but there are some disadvantages. So I already told in previous slide. So if the message is some images or some x-rays or some voice voice message or some video, if the message is some voice video or x-ray images, then if attacker modify the message, the receiver cannot identify the integrity. Actually, in numbers or alphabets, then it can identify. So, for example, we are saying good morning, GOODMORNING, good morning, and we are performing encryption and sending to receiver. If receiver getting instead of good morning, for example, instead of G, the attacker modify G as F. So the receiver received food morning, FOODMORNING. Then here the attacker modifying only one or two bits, then it will changed as food morning. So then the receiver uh, cannot identify the source. It comes from some other person. So there is no authentication and there is no integrity. Okay. So this is by using asymmetric encryption. Okay. If we are used asymmetric encryption or public key encryption, then the first image B. So B is provide only confidentiality. There is also no authentication. So why? Because here the encryption is performed with receiver's public key. So the only person who decrypt the message is the receiver B. Okay. So then they will get original message, but there is no authentication. Why? Because public key of the B is known by everyone. So everyone can encrypt the message with using public key of B and send to the B, but there is no authentication. To provide authentication, so this is the scenario. Okay, now user A want to send the message to user B. Here the encryption is performed with private key of A. Okay, so private key of A, by using private key of A, performing the encryption and sending the message to destination. Now here both authentication is there. Okay, when the receiver receiving the ciphertext by using public key of A, they will get the original message. So here everyone know the public key of A. They when they perform decryption using public key, then they will get message. So original message. So everyone knows uh, the the data comes from sender A. Okay, so this provides authentication, but there is no confidentiality. Why? Because everyone knows the public key of A, so they will receive the ciphertext, they will decrypt it, and they see the original message. So there is no confidentiality, but there is a authentication, and there is that is also called digital signature. So I already told that when we are performing encryption by using private key of A, then that is also called digital signature. Now, so to provide both authentication and confidentiality, we are performing encryption multiple times. So first we are performing encryption with private key of A, and then performing encryption with public key of A. Okay. So this is the ciphertext. So this ciphertext, to decrypt this ciphertext, we need public key of private key of B. So the private key of B is only known to system B. Okay. So in the network there is some confidentiality, and after decrypting it will get some this text. So again it will decrypt with public key of A, then only it will get original message. So here it will getting confidentiality, here it will authenticate the sender. So in this case we are providing confidentiality authentication as well as digital signature. So this PRA provides the digital signature. So this is authentication by using message encryption. But if we are using some images, audio and video, then there is no integrity. Okay, so that's why we are using some function, that is message authentication code or hash value. So now message authentication code. So this is another technique which provides authentication or data integrity. Here how the message authentication code works. So the message authentication code or MAC is generated by an algorithm which uses secret key, and that produces a small fixed size block of data. Okay, here output of the function is fixed size block of data, and that is also called cryptographic checksum or message authentication code. Okay, here the output is called cryptographic checksum or message authentication code that is appended to the message. So here appended means, so this is the original message, then we are appending some code, some MAC or cryptographic checksum here. Okay, so to generate this MAC or cryptographic checksum, we are performing some function called C. So this is a function. For this function, input is original message and symmetric key, secret key. Okay, that is K, and we are performing function and getting this message authentication code. Here M is the input message, C is the MAC function, okay, and K is the shared secret key. Okay, here K is only known to sender and receiver, and message authentication MAC means message authentication code, and this message authentication code is appended to the original message. Okay, so this is the scenario. Here we are taking message and we are performing some function that is represented with C, and we are giving the input key to this function. This is symmetric key. Okay, here only one key is used, that is secret key, and we are getting some code. This is fixed length code, or this is also called authenticator or cryptographic checksum or MAC. Okay, this MAC is appended to, this is the appended symbol, original message. So this is the message we are appending this one. So this code, for this code the equation is function key message. Okay, function is C, first input is key and the second input is message. Then we are getting this code. This code is appended to the original message and sending through network. Now the receiver receiving this message and performing same function to this part, to this message part. Okay, now using same key. Okay, performing same function using same key and getting the fixed length MAC. Now this generated MAC and this received MAC both are compared. If both are same, then there is no modification. If both are different, then there is no integrity. Maybe the message is modified. Okay, so this is the scenario. But if we are sending like this way, okay, there is no confidentiality. But here it having message authentication, but there is no confidentiality. Now what is C? What is the function? How it can be performed will be discussed in next class. Okay, in next class we are going to discuss what are the different type of functions for MAC and what are the different type of functions for hash. Now to provide the confidentiality, okay, to provide the confidentiality, this is the scenario. So here we are taking plain text message M and we are generating the MAC by using function C. Okay, by using some function C. Here we are using K1. Okay, now we are appending this MAC to message. So this is M. Now we are appending fixed length MAC. So this is MAC. Now both are encrypted by using another key K2. So now we are getting the ciphertext. So this is the equation. What we have done is first we are performing C. So C, for that function we are taking two inputs. One is M and another one is K1. So these two are the inputs. After performing this function C, we are getting the result. Now this result is appended to capital M. Okay, here the result is appended to capital M and then we are performing encryption. For this encryption, the result is the inputs are K2 and the function. This is the these two are the inputs and getting the ciphertext. So this ciphertext is transferred through network. Okay, so it provides the confidentiality. Okay, here the original message is not visible to any other person. It provides the confidentiality and and the receiver receive the message ciphertext and performing decryption with key 2. Okay, here the K1 and K2 is only known to sender and receiver. Now after performing decryption it will get the message and code. Now this message is this part. Up to this part the message is we are performing same function C using K1 and getting the MAC code. So this generated MAC code is compared with received MAC code. Okay, if both are same, then the data received data is with came without modification or without deletion. Okay, so now if the attacker want to modify, okay, if the attacker want to modify the data, so first attacker need to know the key. Okay, attacker need to know the key. If the key is to know the key, here the attacker need to perform 2 power k possible operations. Then one operation is matched with original plain text. After that, if he want to modify the message, then he know the C function. So everyone knows the C function, but he also know about K1 also. So he need to identify two different keys. Then only he will modify. Okay. So to find one key, it takes too much time. To identify two different functions, it is very difficult. Okay. Next, uh, another technique, another approach, authentication and to text. Here authentication tied to plain text. Here ciphertext. So here in this video, we are encrypting the original message. Then getting the ciphertext. This ciphertext we apply the function using C. So this is ciphertext. For this ciphertext, we are applying the function in Mac, and this ciphertext is appended with this Mac. Okay, so that's why here authentication is tied to ciphertext. Okay, now we are getting this message. This message is transmitted to network and receiver. So receiver receiving this ciphertext and applying break అవుతుందా? Checking net connection. Net connection is also good. Okay, so you observe here in the first image we are appending to plain text. In second image we are appending mat to ciphertext. So here the receiver receive the ciphertext and applying C function to this upper part, this ciphertext part, and getting the some MAC code. And now the received MAC code and this one is compared. If it is match, then it the message comes with integrity. Okay, and to retrieve the original message, okay, to retrieve the original message, it will decrypt the received text with K2. Okay, only this part, only upper part, K2, and performing decryption and getting the original message. So in this way, the message both authentication and confidentiality provided. Here you know the encryption is symmetric encryption. Okay, this encryption is symmetric encryption. Why? Because here we are using secret key. So to decrypt the message, here we are using the same key. Okay, so that's why this MAC function using symmetric encryption. Now hash functions. The third technique is hash functions. So A hash function processes a variable length message of data that is represented with M. So you observe here in this diagram the original message that is variable length. So that is represented with M as input and produce a fixed size hash value. So this is the fixed size hash value that is represented with small h. Okay, and here we are performing function h. So this is function h. So for this function h, we are taking the input m. Okay, we are taking the input m and performing the function h and getting the hash value. This hash value is also called message digest or MD. Okay, in Mac we are calling cryptographic checksum. In hash functions we are calling hash value or message digest. So both are fixed size output. Okay, so this is hash function, and hash functions provide data integrity. So it also provides data integrity if a change of one bit in plain text m. So if we modify some one bit in plain input block, it will affect many bits in the hash value. So affects high bits change in the hash value. So if we modify one bit here, it will modify more number of bits in the hash value. Okay, so here the m is variable length, and after that we are dividing this m into different blocks, different number of equal size blocks, maybe 512 or 1024. Each block size is 512 bit or 1024 bits, and we are performing hash function and getting hash value. So this hash value is appended to this block. After that, again we are going giving to input to again we are going to giving second input block to hash function and getting the hash value. The output hash value is appended here. So like that we are performing hash functions. So it also provide data integrity. Now cryptographic hash functions is an algorithm for which it is computationally infeasible. So cryptographic hash functions. So he in this way we are getting the hash value. So this is cryptographic hash value. Okay. So this hash function is an algorithm. So this function h is an algorithm which it is computationally infeasible to the attacker. Okay. So to modify the data or to modify the hash value, it is very infeasible to the attacker. So no attacks is significantly more efficient than brute force attack. Okay. No attack is significantly more efficient than brute force attack. So to apply brute force attack, it is dependent on the key length. Okay. Actually, it is dependent on key length. Okay. So here the hash length is fixed size. The hash length is fixed size. For example, hash length is n. The key length is k. Okay. Here n is less than key. So if the key size is okay, if the key size is large, very to the hash function, and the property is a data object that maps to a pre-specified hash result. If we are taking this block, it will match with hash 1, and if we taking second block and it is mapped to hash 2, and if we take this one, it is mapped to hash 3. Okay, so every data object that maps to a pre-specified hash result. So that is one-way property. And collision-free property is two data objects that map to the same hash result. So here if we take input block 4, then it also mapped to same hash function. So when the attacker, okay, when the attacker performing here 2 power n operations, okay, attacking 2 power n operations means brute force attack to this hash value, it will get different number of messages. So which hash value, this hash value belongs to this one or this one, so the attacker don't know, it provides more confusion to attacker. So that is called collision free property. అంటే ఇక్కడ ప్లెయిన్ టెక్స్ట్ మెసేజ్ ఉంది. సో ఇవన్నీ కూడా ప్లెయిన్ టెక్స్ట్ మెసేజ్ బ్లాక్స్. సో మనం ఈ అన్నిటినీ కలిపి క్యాపిటల్ ఎం అంటున్నాం. ఓకే, ఇది వేరియబుల్ అండ్ వీటితో మనం యాడింగ్ మెసేజ్ ఇవి కూడా అపెండ్ చేస్తాం. సో చేసి ఈక్వల్ లెంత్ బ్లాక్ గా డివైడ్ చేస్తాం. నౌ దిస్ సైజ్ 512 ఎవ్రీ బ్లాక్ సైజ్ 512 బిట్ అనుకోండి అండ్ ఇక్కడ జనరేట్ అయ్యే హ్యాష్ వాల్యూ 160 బిట్. సో కొలిజన్ బి ప్రాపర్టీ ఏంటంటే ఈ 512 బిట్ ని హ్యాష్ చేసిన ఇది ఫర్ ఎగ్జాంపుల్ ఇక్కడ ఉన్న బ్లాక్ కూడా హ్యాష్ ఫంక్షన్ అప్లై చేసినప్పుడు సేమ్ 160 బిటే వచ్చింది. సో ఇప్పుడు అటాక్ బిట్ ని రిసీవ్ చేసుకొని 2 పవర్ 1 ఆప్షన్స్ పర్ఫామ్ చేసినప్పుడు సో డిఫరెంట్ రిజల్ట్స్ అనేవి వస్తాయి. 2 పవర్ 160 రిజల్ట్స్ లో ఈ బ్లాక్ అనేది ఇలా ఉంది, ఇక్కడ దగ్గర ఇలా వస్తుంది. సో ఇక్కడ 2 ఒరిజినల్ మెసేజెస్ వచ్చాయి. సో 2 కాదు, మనం తీసుకున్న నెంబర్ అనేది చాలా ఎక్కువగా ఉంటుంది. సో మేబీ 3 వాల్యూస్ కూడా సేమ్ హ్యాష్ వాల్యూస్ ని 3 ప్లెయిన్ టేబుల్స్ కూడా సేమ్ హ్యాష్ వాల్యూని రిప్రజెంట్ చేయొచ్చు. సో రిసీవర్ ఈ హ్యాష్ వాల్యూని రిసీవ్ చేసుకున్నప్పుడు దీన్ని బ్రూట్ ఫోర్స్ అటాక్ చేసినా కూడా మనకి డిఫరెంట్ ప్లెయిన్ టేబుల్స్ ఉన్నాయి. సో ఇక్కడ ఎగ్జాక్ట్ గా ఏ ప్లేస్ ఉంది అనేది అటాకర్ కి తెలియదు. దట్ ప్రాపర్టీ ఇస్ కాల్డ్ కొలిజన్ ఫ్రీ ప్రాపర్టీ. సో ఇది ఎలా అవుతుంది అనేది మనం నెక్స్ట్ డిస్కస్ చేస్తాం. ఓకే, నెక్స్ట్ క్లాసెస్ లో డిస్కస్ చేస్తాం. సో ఇక్కడ 2 పవర్ 160 అన్నారు కదా. సో నో వాట్ ఈస్ సిగ్నిఫికెంట్లీ మోర్ దాన్ బ్రూట్ ఫోర్స్ అటాక్. సో ఇక్కడ మనం డిఫరెన్షియల్ క్రిప్టాలసిస్ కానీ లీనియర్ క్రిప్టాలసిస్ కానీ ఇటువంటి అటాక్స్ చేసినా కూడా ఇక్కడ కీ అనేది వెరీ లార్జ్ కాబట్టి మనం హ్యాష్ వాల్యూ మీద బ్రూట్ ఫోర్స్ అటాక్ బెస్ట్. బట్ ఇట్ ప్రొవైడ్స్ ది కొలిజన్ ఫ్రీ ప్రాపర్టీ కాబట్టి మనం బ్రూట్ ఫోర్స్ అటాక్ చేసినప్పుడు నో యూస్. సో వన్ వే ప్రాపర్టీ ఏంటి అంటే ప్రతి ప్లేన్ టెక్స్ట్ బ్లాక్ కి కూడా మనం సమ్ ఫిక్స్డ్ లెంత్ హ్యాష్ వాల్యూని అపెండ్ చేస్తాం, దాన్ని వన్ వే ప్రాపర్టీ. ఓకే, సో ఇవన్నీ కూడా మీరు సమ్ అల్గారిథమ్స్ డిస్కస్ చేసినప్పుడు ఈజీగా అర్థమవుతుంది. ఓకే, సో మనకి ఈ హ్యాష్ ఫంక్షన్స్ లో మెసేజ్ డైజెస్ట్ అల్గారిథం, MD5 and secure hash algorithm, SHA, secure hash algorithm. Secure SHA-512, SHA-256. సో ఇలా డిఫరెంట్ అల్గారిథమ్స్ ఉన్నాయి. ఓకే, సో ఇలా అలానే వాల్ ఫుల్ WHRI
Excuse me, sir.
వాల్
Voice
ఫుల్
breaking,
అల్గారిథం.
sir. Sir, voice breaking,
సో
sir.
ఇవన్నీ కూడా వాయిస్ బ్రేకింగ్, బట్ అనేది తెలీదు. సో ఇక్కడ రాసినవన్నీ కూడా హ్యాష్. సో ఈ హ్యాష్ ఫంక్షన్స్ డేటా ఇంటిగ్రిటీని ఎలా ప్రొవైడ్ చేస్తాయి? So sender alias receiver Bob. Okay, so sender sending the data. So this is the data, and we are applying hash functions to this data. Okay, hash function and getting some fixed length code. So this is h, and we are appending this fixed length code to data and then sending to receiver. So Bob received the message. Okay, Bob received the message and applying hash to this data part, and getting the h value, generate the h value at receiver side. Now this generated hash value is compared with received hash value. So if both are same, then the data is not modified. If attacker modified this data, so data modified, then this generated hash value is not matched with received hash value. Okay, so if both the data are same, then it will provide data integrity. Now some of the disadvantages are there. So what happens is, here is, so this is sender. So sender sending this, sender sending the data, and by applying hash value, it she will getting the hash code. So this hash code is appended to the data and sending through network. Now the attacker or Darth, so Darth receiving the message and Darth taking this data. Okay, so he removing the hash value and performing and modifying the data. Here the data is modified, so that's why data dash, and applying the hash value to this modified data and getting the hash value. So append this hash value to this modified data and sending to Bob. So Bob receiving the data in the form of this way. Now Bob performing the hash function to this data part and generating the hash value and compare with this hash value. So both are equal. So Bob thought that the received data is correct, but here the attacker modified this data and completely removed this original hash value and append this duplicate hash value. So this is called man in the middle attack. Okay, so to overcome these type of attacks, so we are having different approaches. These approaches provide authentication, correct authentication. Okay, so here the function is h. Okay, so for this function we don't need any input. Okay, for this hash function we don't need any input. So that's why here we are taking, we are, you see the first point here, small h is equals to capital H of m. So just we are giving the input to this hash function, it will generate the hash value. So these are the different scenarios. So the message is given as input to h and getting the hash value here and appended to original message, and then performing encryption with secret key. So this secret key is only known to sender and receiver. Okay, only known to sender and receiver. If the attacker received the message, then attacker doesn't know about the key, so he cannot modify the original data or he cannot modify the hash value. So it provides confidentiality, and the receiver receiving this ciphertext, okay, and performing decryption with same key, and then getting the original message and appended hash value. Now this original message again given as input to this hash function at receiver side and generates the hash value. and this hash value and received hash value both are compare. If both are equal, then receiver authenticates that the received data having the integrity, and here it provides the authentication. This one is provided the authentication. Why? Because the only person who know the secret key is the sender. And another approach is, so this is one form of one type of authentication, and this is another type of authentication. So here the encryption is performed to performed to hash function. So if the attacker receive this message, there is no confidentiality. Okay. But if the attacker is received the message, if attacker doesn't know the key, okay, attacker uh, generate the hash value, but he need to encrypt, but attacker doesn't know the key. Okay, so that's why here attacker cannot modify the message. If attacker modify the message, then hash value change. If the receiver receive this modified hash value and performing decryption, then it will getting different results. Okay, so in this way, we are providing integrity by using secret key. So other than secret key, another approach is, here we are taking the secret value. So S means secret value. So initially we are appending secret value to the message and performing hash function. So hash function takes variable length of input, not fixed size. So here we are appending secret value to the message. The secret value is only known to sender and receiver, and performing hash value and getting hash. This hash is again appended to the message and sending through the network. So if attacker wants to modify the message, then he need the secret value. So secret value is doesn't known to attacker. Now receiver receiving the message and appending the same value to the message and performing hash value and generate the message digest H. Message digest H. Now compare with received secret message. So in this way, providing authentication. So this is another type of. So here confidentiality is there. So why here we are not performed encryption means some of the applications doesn't need confidentiality. Okay, only some applications need confidentiality, and to perform this encryption, it will take more time, more computational time. So if we need data secure, then only we are performing encryption here. Otherwise, we are not performing encryption. And then digital signature. So digital signature, I already told that digital signature is used to is similar to use the hash function for message authentication, and the hash value of the message is encrypted with user's private key, then that is called digital signature. So you see the scenario here. Okay, you see the scenario here. So message is given as input to hash function. The output of the hash value is encrypted with private key of A, and then we are sending to receiver. Now receiver receiving the message and generating hash value, and the received hash value is decrypted with public key. Here the generated hash value is encrypted with private key of A, and the received hash value is decrypted with public key of A, and compare, and then getting the authentication, source sender authentication. Now everyone knows the okay, everyone knows the attacker also know the public key of A. So he also compare, and he will also authenticate. Okay, so but attacker cannot modify the message. Why? Because attacker doesn't know the private key of A. Okay, if attacker knows the private key of A, then attacker can modify it. Okay, now to provide more security to this approach, okay, so the another scenario. So here the hash value is protected by using performing encryption with private key of A, and the message is again we are performing symmetric encryption. So I already told that we need more confidentiality to our data. So this is the scenario. So if we doesn't need any confidentiality to our data, then we follow this approach. Okay, so for example, I am sharing PPT with you, so it is doesn't confidential, but you have to identify the సోర్స్. సో, అంటే పీపీటీ అనేది నా దగ్గర నుంచే వచ్చిందా లేదా అనేది చెక్ చేయడానికి నేను ఇక్కడ ప్రైవేట్ కీ యూజ్ చేసి సెండ్ చేస్తాను పీపీటీని. మీరు రిసీవ్ చేసుకుంటారు. సో, ఆ మెసేజ్ అనేది కాన్ఫిడెన్షియల్ కాదు కాబట్టి ఎన్క్రిప్షన్ పర్ఫార్మ్ చేయట్లేదు. అది నేను క్వెషన్ పేపర్‌ని ఎగ్జామ్ సెల్‌కి పంపించాలి. నేను పంపించాలి కాబట్టి నా ప్రైవేట్ కీ యూజ్ చేస్తాను. సో, వాళ్ళు నా పబ్లిక్ కీ యూజ్ చేసి అథెంటికేట్ చేస్తారు. అండ్ క్వెషన్ పేపర్‌కి కాన్ఫిడెన్షియాలిటీ ఉండాలి కాబట్టి సీక్రెట్ కీ యూజ్ చేసి ఎన్క్రిప్షన్ పెర్ఫార్మ్ చేస్తాను. సో, ఇక్కడ ఇలా పెర్ఫార్మ్ చేసామంటే దీన్ని డిజిటల్ సిగ్నేచర్ అంటున్నాం. అండ్ ఇక్కడ కాన్ఫిడెన్షియాలిటీ ప్రొవైడ్ అవుతుంది. సో, ఇక్కడ అథెంటికేషన్ ప్రొవైడ్ అవుతుంది. బట్ నో కాన్ఫిడెన్షియాలిటీ. ఎందుకంటే ఈ అప్లికేషన్ ఇక్కడ పీపీటీకి కాన్ఫిడెన్షియాలిటీ రిక్వైర్‌మెంట్ లేదు. ఇక్కడ క్వెషన్ పేపర్‌కి కాన్ఫిడెన్షియాలిటీ కావాలి యాస్ వెల్ యాస్ అథెంటికేషన్ కావాలి. సో, బేస్డ్ ఆన్ ది అప్లికేషన్ వి హావ్ టు చూస్ ద అప్రోచ్. సో, ఇక్కడ కంప్యుటేషనల్ టైమ్ అనేది తక్కువ ఉంటుంది. ఎందుకంటే ఎన్క్రిప్షన్ పెర్ఫార్మ్ చేయలేదు. సో, ఇక్కడ కంప్యుటేషనల్ టైమ్ అనేది ఎక్కువ తీసుకుంటుంది. సో, దట్ ఈస్ uh, authentication and confidentiality by using digital signature. సో, ఇక్కడ డిజిటల్ సిగ్నేచర్స్ అంటే ప్రైవేట్ కీ యూజ్ చేస్తున్నాం. జస్ట్ హ్యాష్ ఫంక్షన్ ఇక్కడ సిమెట్రిక్ కీ యూజ్ చేస్తున్నాం. చూడండి ఇక్కడ ఓన్లీ కేకే అని మాత్రమే ఇచ్చాం. ఎక్కడ ప్రైవేట్ కీ యూజ్ చేయాల. ప్రైవేట్ కీ యూజ్ చేసామంటే దాన్ని డిజిటల్ సిగ్నేచర్ అంటున్నాం. అండ్ ఇవే కాకుండా మనకి డిఫరెంట్ అప్లికేషన్స్ ఉన్నాయి. సో, మెసేజ్ అథెంటికేషన్ చూసాం, డిజిటల్ సిగ్నేచర్స్ చూసాం. ఓకే, నౌ వన్ వే పాస్వర్డ్ ఫైల్. So, operating system stores a hash of password rather than the original password in the computer. సో, మనం కొన్ని వెబ్‌సైట్స్‌కి వెళ్ళినప్పుడు పాస్వర్డ్స్‌ని సేవ్ చేస్తాం. యూజర్ నేమ్, పాస్వర్డ్‌ని సేవ్ చేస్తాం. సో, అవి ఎక్కడ సేవ్ అవుతాయి అంటే మన సిస్టమ్‌లో ఒక పాస్వర్డ్ ఫైల్ అనేది ఉంటుంది. సో, ఆ పాస్వర్డ్ ఫైల్‌లో డేటా అనేది డైరెక్ట్‌గా స్టోర్ అవ్వదు. హాష్ వాల్యూస్‌లో స్టోర్ అవుతుంది. సో, ఇప్పుడు ఎవరైనా అటాకర్ మన సిస్టమ్‌ని యాక్సెస్ చేసినా, లేదంటే ఎవరైనా మన ఫ్రెండ్స్ మన సిస్టమ్‌ని యాక్సెస్ చేసినా, ఆ పాస్వర్డ్ ఫైల్‌ని ఓపెన్ చేసినప్పుడు ఒరిజినల్ పాస్వర్డ్ అనేది కనిపించదు. సో, హాష్ వాల్యూ ఆఫ్ ది పాస్వర్డ్ అనేది స్టోర్ అయి ఉంటుంది. ఓకే, సో, ఇలా పాస్వర్డ్ ఫైల్స్ స్టోర్ చేయడానికి మనం హాష్ ఫంక్షన్స్ అనేవి యూజ్ చేస్తాం. అలానే రాండమ్ నంబర్స్ జనరేషన్ చేసేటప్పుడు కూడా ఈ హాష్ వాల్యూస్‌ని యూజ్ చేస్తాం. సో, దీస్ ఆర్ ద డిఫరెంట్ అప్లికేషన్స్. సో, ఇవన్నీ కూడా మనకి మెసేజ్ ఎన్క్రిప్షన్, మెసేజ్ అథెంటికేషన్ కోడ్ అండ్ వాల్యూస్ ఇవి మెసేజ్ అథెంటికేషన్‌తో పాటు డేటా ఇంటిగ్రిటీని ప్రొవైడ్ చేస్తాయి. అండ్ సెండర్ అథెంటికేషన్‌ని కూడా ప్రొవైడ్ చేస్తుంది. ఓకే, సో, in today's session we are getting some problem with voice. So, if you have any doubt in the concept, just you once read the textbook. Okay, then if again you will not understood, you will ask in next session also. Okay, so just read once at least today topic. Okay,